Welcome back. So today we are going to be talking about air resistance, and more specifically, air resistance that's able to lessen the force of a collision. So two objects running into each other. Up on the board, you'll see we have our standard. So we are applying our scientific knowledge of engineering and science, and we are going to design, evaluate, and refine a device to minimize the force of a collision. Tomorrow we're going to be doing an egg drop. So we're going to take an egg, we're going to drop it off of the balcony of the gym, and it's going to hit the floor. Your job is to try to get that collision with the least amount of force possible. We don't want it to hit very hard. We do not want to break this egg, okay? So by the end of class, you will design, create, and test a device to lessen a collision between two forces, okay? So here's what we're going to do. Let's start first with these two objects. This roll of paper towels is much heavier than this very small eraser. So I want you to pause this video right now and make a hypothesis. Which one of these are going to hit the ground first? Okay, so go ahead, pause. All right, now let's test this. I'm going to drop both of these from the same height, and I'm going to do my best to drop these at the same time. Ready? 1, 2, 3. You see that both these objects hit my desk at the exact same time. Here's why. Newton's law says that our net force, our acceleration, has to equal our net force divided by our mass. So let's say this roll of paper towels had a mass of 10 kilograms, and this eraser had a mass of only 1 kilogram. What we need to do is we need to figure out what was its net force. So this net force would equal its mass times gravity. For this instance, we're going to say that gravity equals 10 meters per second. Okay? So if we take 10 meters per second times 10 kilograms, that gives us a net force in the downward direction of 100 newtons. So the gravitational force in this direction should be 100 newtons. So our gravitational force. Same thing for this book. We need to take its mass times gravity. So 1 times 10 would again give me 10 newtons. So we have 10 newtons for our gravitational force. So these two objects, now we can figure out its acceleration. Acceleration equals its net force divided by its mass. For this roll of paper towels, we would then take its net force, so its net force being 100 newtons, and we need to divide that by its mass, which is 10 kilograms. If we do that math, we get a total of 10, and the units for acceleration will be in meters per second squared. So you'll see that this roll of paper towels was falling at 10 meters per second squared. Now let's figure out what it was for the eraser. So same thing over here, we are going to take its net force, so net force being 10 newtons, and we are going to divide that by its mass. So divide by mass, and when we do that, that is 10 divided by 1. That gives us an answer of 10 meters per second squared. So this eraser was also falling at 10 meters per second. Both of these objects were falling at the exact same speed. So what we're going to do next is we need to look and see how air resistance is able to slow down an object as it is falling. All right, now we need to talk about air resistance. So what is air resistance? Air resistance is the greater the cross-sectional area of an object, the more air resistance it will have. So for example, if we take a look at this piece of paper, it has a very large cross-sectional area. If we take a look at this eraser, it's got a very small cross-sectional area. My question for you is, what's going to happen when I drop this piece of paper and this eraser from the same height at the same time? Which one's going to hit the ground first? Go ahead, pause your video, and make a prediction. All right, so now we are going to test this. I'm going to drop this piece of paper, drop this eraser, same height, same time, and let's see what happens. That piece of paper fell a lot slower than that eraser. Let's talk about why. So this piece of paper has a mass of 1 kilogram. The only thing different from that eraser is that it now has 2 forces acting upon it. That air resistance gives us a force in the upwards direction. We still have the same force pointing in the downwards direction, which is gravity. So this number is going to be our mass times gravity. So this is going to be 10 newtons. Since this is in the downwards direction, we indicate that with our negative sign. This force is pointing down. Air resistance is pointing up, therefore it will be positive. Our air resistance in this case is going to be 6.8 newtons. So the force that the air was pushing up on this piece of paper was 6.8 newtons. Gravity is still larger than the air resistance, which is why this paper fell down. It didn't go up, it fell down. So let's take a look at how we can now calculate our net force. So our net force we need to figure out by adding up our 2 different forces. So we have 1 force pointing down, 1 force pointing up. If we subtract 10 from this, we'll get a negative number. So our force was in the downwards direction, going 3.2 newtons. That was the force in the downwards direction. And again, that was just taking 10 minus 6.8. That gave us our net force of 3.2 newtons. This is now our net force. I want to figure out the acceleration of this piece of paper. To figure out acceleration, I need to take my net force divided by my mass. So I'm going to take this 3.2. I will draw a box around this. I need to take my net force, and I need to divide that by my mass, which was right here. So I'm going to write 3.2 newtons divided by my mass, which was 1 kilogram. This is going to give me my acceleration. Again, we are using this equation right here. So my acceleration is going to be 3.2 meters per second squared. And that was the acceleration of this piece of paper. It was falling a lot slower than our eraser, which was falling at 10 meters per second squared. So this shows you what we're trying to accomplish tomorrow. We're trying to do an egg drop, so we want our egg to fall as slow as possible, because the slower our acceleration is, the less force that it is hitting the ground with. And we do not want to crack these eggs. So we are trying to increase our air resistance to decrease our acceleration. Again, we want it to fall slow and hit the ground soft. So now you're probably wondering, why is this important? Why do I need to know this? Here's why it's important. There are certain people that are survivors of hurricanes and earthquakes that need supplies. Their home was destroyed. They need supplies, they need water, food, and other supplies to survive. It's not always possible for our airplanes to land at these places after they've been destroyed by a hurricane or an earthquake. So sometimes airplanes need to fly in, drop a package out of the air, and have it land softly so that it doesn't destroy any of the supplies inside. So tomorrow we're going to try to mimic this, and we want to make our own design and try to not break our supplies, which in this case will be eggs. So go ahead, fill out your worksheet, and that will be due tomorrow.